Alright, in this last video, we will go over some examples of sampling distributions and Central Limit Theorem. I'm going to go over slides 24 through 39. Alright, so go back to slide 24 and let's read this first example. The figure shows the mean distances traveled by drivers each day. And for me, on Tuesday, Thursdays, I don't drive at all, so that will be 0. But on the Wednesdays and Fridays, I have to drive to Woodbridge, so that will be like 30 miles. So, but this is the mean distance. This is the average. How many miles do you drive per day? It says you randomly selected 50 drivers, ages 16 to 19. But when I looked at this, oh, maybe that's why I drew this red box around it, because this shows the average miles driven each day by age group. So the first box right there, the first picture, that's the age group that we're looking at. So 16 to 19, so they drive about 20.7 miles by average. Like myself will be in this third category, 30 to 49. They drive a little more, I see, 37 miles per day. But we need to ignore this second, third, fourth, and fifth group because we're only looking at a random sample of 50 drivers in this first category, the teen drivers. Okay, so what is the probability that the mean distance traveled each day is between 19.4 and 22.5 miles? I think that probability will be like reasonably high because look, the true mean is 20.7 and that is in between these two bounds, right? And it says assume the population standard deviation is 6.5 miles. We're going to do this using normal calculator, but we're not going to be able to use the mean and the standard deviation of the population, okay? All right, so I'm going to highlight some things here for you. The mean, well, they didn't spell it over here, but we can read from this chart right here, the graph right here. The mean is 20.7 miles. So that's going to be the mean that we're going to be using because mean of the sampling distribution of sample mean is equal to the mean of the population. So we can just use that. N is the sample size. We randomly selected 50 drivers, so N is 50. And the standard deviation of the population is 6.5. They gave us that number. And what we're going to have to do is use these three to find the mean and the standard deviation of this particular sampling distribution. Okay, so I'll take notes here and then we'll go open up StatCrunch together. Mean of sampling distribution that we're going to be using is the same as 20.7. Okay, but standard deviation, or we call it standard error, standard deviation of sampling distribution of the sample mean. Remember, we have to follow that formula. I'll open up that formula for you. This one right here. Okay, we're going to need to use that formula. I'll copy this. Okay, I'll copy this down on slide number 24. And we're going to use this formula. Okay, so what we have to do is I'll use a Word doc to type it. And I think I actually did the work on the next page. So what I have to do is divide the population standard deviation. Let me bring it to the side a little bit. Population standard deviation, which was 6.5 by square root of the sample size. Square root of the sample size. And sample size was 50, all right? So that's what I'm going to have to do. All right, let me go ahead and type this into a calculator so that I can find out what this is, okay? 1 second, I'll go open up a scientific calculator and type in 6.5 divided by square root of 50. And that came out to be approximately 0.9. So this is it. That is the standard error that we're going to have to use. I will put this on the slide here, okay? Give me 1 second. I'll add this picture here. So that's from the calculator. And that's the formula I used. So the standard error is 0.91923. I'll just go ahead and round this to this, okay? So these are the two numbers that we're gonna have to use, okay? These are the two numbers that we're gonna have to use. I'll highlight this. All right, so now go open up your normal calculator. The sample size is 50, is greater than 30. So by central limit theorem, we can assume that the sampling distribution can be approximated by normal distribution. So I'll go open up my normal calculator now to find the probability of seeing a sample mean that is in between 19.4 and 22.5. So take a look. I will go to StatCrunch. I have to log in first, it looks like. Give me 1 second. All right, open up a normal calculator. Stat calculator normal. And let's enter all those numbers that we found. What was the mean? The mean was, go to between calculator because we're trying to find the area or probability between 19.4 and 22.5. But the mean was 20.7. Standard deviation, it will be wrong if you type in 6.5 here. It's not 6.5. The standard deviation of sampling distribution of sample mean follows that formula. So you're going to have to type in 0.9192. And that's it. You click on compute. Ta-da! The probability of seeing a sample mean that's in between 19.4 and 22.5 mile is very high. About 90% chance of seeing such average. So that is how you can do this problem. That is how you can do this example. And I think I took screenshots of these. So if you take a look at this, okay, I am using the mean of 20.7. I'll make this a bit bigger. I am using the mean of 20.7, but the standard deviation, that 0.919238, that's from doing standard deviation of the population divided by square root of 50, okay? So if you do that, enter the lower bound and the upper bound, you'll be able to find the desired probability, okay? So very common students miss this because they just type in 6.5, but that's not how you would do the sampling distribution problem. When they have a sample size of 50, you're going to have to divide the population by square root of 50. Population standard deviation by square root of 50, okay? So that was one example. All right, let's see if there's another one. Or maybe I may have just slides talking more about it. All right, so this is talking about what we did from the central limit theorem. You see the sample size was 50, and 50 is definitely greater than 30. The sampling distribution of sample means is approximately normal. That's why we were able to use the normal calculator to find the probability. And look, they are writing down that the mean is 20.7, and the standard deviation of the sampling distribution is 6.5 divided by square root of 50. So approximately the same thing that we got. And now look, they love to do it by converting it into z-scores, but we were able to skip that. How? We were able to skip this z-score work because we use technology, right? But if you don't have StatCrunch or TI-84, you're going to have to convert it into a z-score so that you can use that standard normal table in the back of your book, okay? But I'm going to just skip it because I don't need this, right? We are allowed to use technology to find the probability. Okay, you have normal CDF or you have StatCrunch's normal calculator. So this slide, I'm just gonna go over it, but just want to see if we got at least got the same answer. 0.8957, is that the same as what I got? I took a screenshot. Where is it? 0.8962. And they got 0.8957. It's a little bit different because I think they rounded the population standard, the standard deviation as 0.9 instead of going with the more exact one. But, got the same thing. Ours is more accurate, we'll say, okay? But if you want to look through these, because if you really like the z-score method and using the table method, slide number 27 and 28 is using that, but I was able to skip some of this mid-work because we were using technology to find the probability, okay? All right. So of all samples of 50 drivers, okay, ages 16 to 19, we would be able to say about 90% of those 50 samples will drive a mean distance each day between 19.4 and 22.5 miles as shown in this graph, okay? So if I go out there and ask 50 drivers in this age group, 90% chance that they drive in between 19.4 and 22.5 miles. Their average will be in between those two numbers, okay? So if I go out there and get, let's say, 50 drivers in this age group, and I found their average, and then I get something like 45 miles, oh, either I sampled a very biased sample, let's say that's people who drive from like West Virginia to DC, I don't know, or maybe that sample mean that they were suggesting is wrong. But that's something that we will talk about in the third unit. But right now, we are just finding the probability of seeing such sample mean using normal distribution. Okay, so this implies that assuming the value of mu equals 20.7 is correct, about 10% of such sample means will lie outside the given interval. Okay, all right, let's see this. Another example, the mean room and board expense per year at 4-year colleges is $10,453. I thought that would be more expensive. Maybe it is more expensive now, but so this is the room and board. Like, I don't know if this includes food too, but all right, so let's say that's the average. Okay, you randomly select 9 4-year colleges. Now that sample size is a little too small because remember, by central limit theorem, you want that number to be at least 30, right? So I'm wondering if normal distribution is appropriate for us to use. But remember the two things, right? Either the sample size is at least 30 or the population itself is normal. Okay, so let's keep on reading to see if the population is approximately normal. What is the probability that the mean room and board is less than $10,750? All right, assume, oh, look at this part. Assume, whoopsies. Assume that the room and board expenses are normally distributed. Now listen, this part may seem not so important, but absolutely we needed this piece, okay? Assume that the room and board expenses are normally distributed. They didn't need to include this part if that sample size was at least 30. But because the sample size was only 9, we needed to know this to go on with our work. And it says standard deviation of 1650. Okay, so I think down here I just noted everything, but let me go ahead and open up a Word doc so that I can just type up everything for you, okay? So first, starting with the mean that we're going to use. Remember, the mean is equal to the population mean. So that was 10,453. But standard deviation, or standard error, I will call it, standard error, is not going to be 1650, right? We have to follow that formula, and that formula is population standard deviation divided by square root of n. Population standard deviation was 1650, and I need to divide this by square root of n, and sample size was what? Oh, only 9. All right, so what's that going to give me? Oh, I think I can just use this. So I'll do 1650 divided by square root of 9 is 3. So if I do that, I will get 550. So this number, I wonder if I can just highlight this number. Yep. And this 550 are the numbers that I'm going to use on my normal calculator. Look. So over here on the normal calculator, I will type in the mean of 10,453 and standard deviation of 550. Now, what was it that they wanted? They wanted the probability that the room and board is less than 10,750. Okay, so less than 10,750. We're about to get the answer. But I want you to take a look at what I entered. The mean is 10,453. Standard error is 550. And this is what we're looking for. And we were able to use the normal calculator because they said room and board expenses are normally distributed. That's the population is normally distributed. So we can use normal calculator to find the probability of on the sampling distribution. Click compute. Ta-da! About 71%. That's how you can do this, okay? So about 71%. So keeping that in mind, let's go check out the next couple slides. I think they're going to do a nice job summarizing everything. Oh, look, that's my handwriting from one semester, I think. So this is kind of just showing you how I got this 550 entered in this normal calculator and everything else, exactly how we just did it together. All right, because the population is normally distributed, didn't matter, the sample size was only 9, it was so small, but they did mention population is normally distributed. You can use the central limit theorem to conclude that the distribution of sample means is normally distributed. So if that part wasn't covered, that part wasn't mentioned in the problem, I would have said, no, I don't think we can do this. We have no idea if the sampling distribution of sample mean is normally distributed because the sample size was too small. But thank goodness they mentioned it. We were able to do this problem for them. The mean is the same as the population mean, but remember the standard error, we had to do this formula, right? Follow this formula, and that's how we got 500 and, there's a 2 equal sign here, $550, okay? Like, you know, our slide likes to go through the z-score method, but we skip this using StatCrunch, right? But they found the area to the left of 0.54, and that came out to be about 71% too. Okay, so up to you. If you want to use z-score and the table method, it's going to take you about like 3-5 more minutes. But if you can also use your StatCrunch technology, okay? All right. Now they're talking about you can check this answer using technology. For instance, you use TI-84 plus and you can use the normal CDF. You enter the lower limit, the upper limit, the mean and the standard deviation in order, separated by commas, and they'll give you the same probability, okay? So about 71% of such samples with n equals 9, sample size 9, will have a mean less than $10,750, and about, the complement of it, 100% minus 71%. About 30% of these sample means will be greater than 10,750, okay? Think we have, all right, so the last example, so slide 36 through 38. All right, let's look at 36. More examples, just more, okay? Some college students use credit cards to pay for school-related expenses. For this population, the amount paid is normally distributed with a mean of 1615 and a standard deviation of $550. Now look, this is population number. So you know you're going to just use 1615 for the mean, but we're not going to use 550. If we are looking at sample of size, I don't know, 25, then we're going to have to use the formula, right? All right, let's look at the first question. What is the probability that a randomly selected college student? So we're picking what? One person, okay? Think of this as having a sample size of 1, okay? Now this, we don't really have to follow that formula because this is just problems from like our previous section, 5.3, just finding the probability. What is the probability that a randomly selected college student who uses a credit card to pay for college school-related expenses pay less than $1,400? Now, I'll go ahead and just do this right now using my normal calculator. What did they say that the mean was? Mean was 1615 The standard deviation is 550. Now, I am using 550 because the first question isn't about sampling distribution. This is not a sample of 10 or sample of 20. This is one college student selected, okay? So that's just a straight up normal distribution problem. So enter 550 and less than 1400. So the answer for the first question is there's a 35% chance that I will see someone who used less than $1,400, okay? Now, the next question is a little bit more, because this one is now about sampling distribution. Use randomly selected 25 college students. In that case, we don't get to use that 550 as a standard deviation anymore. Now here, the mean is the same. 1615 is the same. But we're going to have to find the standard error, okay? We divide the population standard deviation by the square root of the sample size. So let's figure out what that is, okay? So I will do 550 divided by square root of 25, which is 5. So this time I need to use the standard error of 110, okay? So over here, I will enter 110. So the probability will come out to be different. About like less than 3% chance that if I ask 25 college students, their average will come out to be less than $1,400. Okay, you see the answers are very different, right? The first one, when I looked at just a single student, if just one student having a credit card debt of less than 1,400, it was about 35% chance. But if I ask 25 college students and get their average, the probability that their average of these 25 college students were to be less than 1,400 is less than 3%. So why are these answers very different? Because really we're asking for two different questions, right? The first one is about finding the chance that one person is using less than 1,400. The second question is about you're asking 25 different people, and then their average coming out to be less than 1,400, and that was much less than the answer from the first one, okay? All right, let's go and read the summaries. Just wanted to show you how to quickly get those numbers first, okay? They were a little different, right? If it's just a randomly selected college students, then you go with the population standard deviation of 550. But if it was a sample of 25 college students, that now becomes the sampling distribution problem. So, for the first case, you are asked to find the probability associated with a certain value of the random variable x. Now, again, they do the z-score miss, but let me just go read the probability. So, about 35% chance that randomly selected student, one student, will paid less than 1,400 is about 35%, okay? So that matches our answer. All right. The second question, though, we had to use the standard deviation. Look at the standard deviation here. 550 divided by square root of 225. And that's why I enter 110 as the standard error in my normal calculator, right? And now look, they also got that same decimal, about less than 3% chance of that happening. So this slide, 36 and 37, they look a little different from what we did because I never use that z-score method. I use technology, but what we are seeing is that the answers are the same. So you can check the answers in part 1 and 2 using technology. For instance, you can use Excel, okay? They also have this function called norm.dist, okay? And you can find that same probability. Our technology choice was just StatCrunch. So let's look at comparing those two different answers. Although there is about 35% chance that one randomly selected college students who use a credit card to pay for school-related expenses will be less than $1,400, okay? So I wouldn't consider that to be unusual, okay? There is only about 3% chance, if you look at the group of 25 students, that the mean amount of sample of 25 college students will pay is less than 1,400, because there's only 3% chance that the mean amount of a sample of 25 college students will pay is less than 1,400. Remember, like we compare that to 5% because 3% is less than 5%. We will say this is an unusual event, okay? So let's say that I believe this, what they said is completely true. And I go out and ask 25 college students. And then I average their credit card debt. And I found out that the mean is only, let's say, $100. Then, I will start having doubts. I will wonder, what they said about this true population mean, could that be really true? Because if that was true, the chance of me seeing a number that's less than 1400 is like only 3%. So then I start doubting, the numbers that were given to me. Now I'm kind of talking about the hypothesis test and everything, but that's going to be for Unit 3. But this unit, Chapter 5, I want you guys to practice finding the probability. And the last one is on finding the probability of sampling distribution. So as long as you are okay finding the standard error using that formula, population standard deviation divided by square root of the sample size, and know how to use a technology of your choice to find the probability, you will be okay. So I want you guys to try 5.4 homework and send me links to any questions that are confusing to you, okay? But that covers all parts of lesson 5.4. That was on sampling distributions and the central limit theorems.